Okay, this is question 6 from the paper 2 revision on um, differential calculus. We're given another function, 48 divided by x plus kx squared minus 58, where x has got to be bigger than 0 and k is a constant. The graph of the function passes through that point. P is the minimum. We need to sketch the graph indicating the minimum point and the x-intercepts. Okay. Well, obviously, our first conundrum is the fact that we've got k, right? We're told it's a constant, but we don't know what it is just yet. Um, so what we're going to do is we're going to utilize this information here. We know that the 0.42 has to work with that. If I substitute that back into the formula, where 2 is the same as 48 divided by, I didn't want to write 2 there, I wanted to write 4 plus k times 4 squared minus 58, then we will have our solution. So this turns into 2 is 12 plus 16k's minus 58. 12 minus 58 is negative 46. So we get 48 is equal to 16k's. Again, I just combine those, so that'd be negative 46, and then I'd add 46 to both sides. So k has got to be 3, because 48 divided by 16 is 3. So now I have my function. My actual function is 48x to the negative 1 plus 3x squared minus 58. That's my function. Now, this is paper 2. So totally, you could try to set that equal to 0 and solve for your, or take the derivative, then solve. That would absolutely work. But it's paper 2. I'm just going to graph this thing because what I want at the end is a graph. Now, the one nice thing about this is they've already told us the bounds that we're looking for. It's got to be bigger than 0. X has to be less than or equal to 6. We go from negative 30 to positive 60. So before I do anything else, I'm going to adjust my window. And I'm going to go from, I'm going to do negative 2 to 10 is fine. I'm going to do from negative 45, and it said 60, so I'm going to go to 75, just so I get this thing zoomed in where I'll be able to see it. Okay? So now I'll insert that equation. Sorry, and I just need to make sure I got this right. So 48 divided by x, that's my first one, plus 3x squareds, minus 58. Okay, so we get kind of a really interesting graph that looks like this. And the only other thing that we need to make sure we have is we gotta have a minimum point because that's what it said. So I'm just gonna do the trace function. And we have a 0 there. We have a minimum at 2, negative 22, and another 0 there. So all we have to do is reproduce that. So it's a sketch. It's going to look kind of like a wonky value. So we need to identify that point. We need to identify that point. We definitely need a minimum. It would also be valuable because we're doing this to, no, I think that's good enough. So just going through and getting these values in, 0.8610. My minimum was at, I think it was 2, -22, if I remember right. And I don't remember my math, or my 2, -22, and 3.9. Is that my 0? There's my 0. So right about 3.90. Now the only other thing that we should probably add is that we know that this is the point 4.2. So, but if we have those, I think we're good, and I think we've done everything we need for that. Okay, so that is that.